In this video, we're going to present our work, the uncertainty-aware 3D object-level mapping using DeepShape priors. The 3D object-level mapping is a task that estimates the object shapes and the relative poses in the scene. The problem is challenging when the object models are not available. In this work, we develop a mapping system that can simultaneously reconstruct object models, relative poses, and associated uncertainties in the scene. Our framework is based on the 3D generative model. It takes the latent code at the input and decodes to a 3D object model at the category level. In this example, the generative model can reconstruct different chairs by varying the input code. To reconstruct the object in the scene, we estimate a 9 degree of freedom pose that can transform the object from the object model frame to a global reference frame. And in the runtime, we jointly optimize the latent code and the object pose. We initialize the latent code with the 0 vector, and the object pose can be initialized from an existing pose estimator. To consider the uncertainties, for each object, we estimate the covariance for the latent code and the object pose, and integrate them into our probabilistic optimization framework. And our optimization framework includes two loss functions, a 3D surface loss and a 2D rendering loss. The 3D loss minimizes distance between the 3D point cloud measurement and the reconstruct object surface. The 2D loss minimizes the errors between the rendered depths and the observed depths, which can effectively constrain the object scale during the optimization. The object shape and pose and the associated uncertainties can be finally estimated using the iterative optimization. The final estimate uncertainties can tell us how good our reconstruction is. And here are two examples on the indoor ScanNet dataset. We can see the object shape and pose can be gradually recovered when minimizing our loss functions. And here's an example on the outdoor kitty dataset. We can see the optimization is converged and the object shape and pose are correctly estimated. And for a large scene, we can perform the optimization on each individual object and estimate its shape, pose, and the associated uncertainties.